Okay, Wayne, I've got a little demonstration video here for you of the retract controller that I've put together for you. This is one of my standard C3DL retract controllers like you see on the website. And as it turned out, the default programming that I put on this board was perfect for your retracts. I got your retracts here mounted to a board that's clamped to my table. I don't remember what you told me the brand was on these, but they are really nice. They're smooth. They really work well. It looks like they have brakes. That's a really nice set of retracts. I've got this servo here connected up to show you the action of the gear door sequencing. And this, of course, is the 2-cell battery. Now, I'm going to go over some things in this video, Wayne, because I'm going to use this as a sort of a demonstration video for this circuit. I have pictures of it on the website, but I don't really have any videos showing the guys what it will do and some of the features. So if you don't mind, I'm going to go over some of that so that others can see what this thing is capable of. As far as the battery is concerned, you told me your retracts were a 2-cell 7.4 volt 2-cell. So that's what I have connected, but the controller doesn't really care what the voltage is used on the retracts. That voltage is just passed right straight through the H bridges. So if you've got retracts that take a 5 volt battery, 6 volt, 7.4, maybe even there are some retracts out there that require a 12 volts, like a 3-cell. It's no problem. The controller will handle up to, I think it's 40 volts, so you're good there. The controller itself plugs straight into your receiver. I've got my servo tester here that I'm using to provide the signal, and it assumes that we're going to have an operating voltage on the receiver of between 4.8 to 6 volts. If you've got a high voltage receiver, I'll have to fix you up with a little regulator to go between the receiver and the controller, because the controller is not made for higher voltages, but that won't affect the voltage going to the retracts. So I'm gonna go over now some of the functions so you can see what the controller is doing. We're plugged into the servo tester right now, but I don't have the power on, so I'm going to show you what happens as soon as the plane comes on. My controller is designed to immediately move the landing gear to the down position, and I have found over the years in building these that is an advantage over allowing the controller to move the gear to immediately to whatever position the gear switch happens to be in. Because what I've found is that a lot of times modelers would forget to check the position of the gear switch, and they might have the plane sitting on the ground or something, and maybe they've flown it a time or two and turned it off, and then it's sitting on the ground and they turn it on again, and they don't check the position of the switch, and the gear come up and collapse it and break something or break a prop or something like that. So the first thing that happens always when the plane comes on is that the gear are going to move to the down position. Now you see your gear door opens, and then your retracts come down. They're coming up here, but that's actually the down position. And then you saw the gear doors close and the landing lights come on. Now we're going to reverse that just so you can see simply what the opposite of that is. When you give it the gear up command, the gear door opens, the gear come down, and then our lights will go off. I'm sorry, as soon as the gear door closed again, the lights go off. So I kind of butchered that up. Let me try that again. Got a lot going on here. Gear door opens, gear come down, the gear door will close, and then the landing lights. And we'll reverse that. The gear door will open, the gear come back down, back up, I'm sorry, go up, the gear door closes, and then the landing light goes off. Now you'll notice on the board here you've got a row of dip switches on the bottom right hand corner of the board, and these control the various features of the circuit. Switch number 1 is off, and that has it configured for a 2-gear system. There's actually a third output here that's not being used right now, but that's for nose wheel or tail wheel. And if your model has a 3rd gear, great. If not, you still can use this controller. You just turn that third output off. Switch number 2 reverses the direction of the nose wheel or tail wheel, so that if the nose or tail wheel retract happens to move in the opposite direction, you can change it from the board without any problem. Switch 3 right there is controls the delay function. When it's up, there is no delay. When it is down, there is a delay. I'll show you that in just a second. On the right main, to simulate the action of a lot of World War II warbirds. Switch number 4 in the down position turns your gear doors on, and that's the gear door sequencing that you saw a moment ago. And switch number 5 determines whether or not the gear doors close back after the gear are down. Some planes they do, some planes they don't. So switch number 5 allows you to configure it for like either a P51 or a P47. And switch 6 isn't used on this circuit. And of course, the landing lights plug in and are removable, so if you don't want landing lights, you just unplug those, and you might need them in the future. But let me show you one more time, just so you get an idea of what's going on. We're going to toggle our channel. The gear door opens, the gear come down, gear doors close, and the landing lights come on. Now let me also show you, let me go ahead and bring the gear back up, and then when they come down this next time, I'm going to show you that we've got the stall current set correctly. Okay, now this time when I bring the gear down, this one closest to me, I'm going to stop it with my hand so you can see that the stall sequencing is working. Okay, this gear's coming up. You hear it and there we go. And of course, when you get ready to go the other way, it will correct itself, bring them both back up again. There's one other feature I want to show you, and that's called the quick up, quick down that I have in this programming. Let's say you got the gear up, and you decide you're ready to land, and so you bring the gear down, and the gear come down or start down, and then you see there's somebody on the runway. You can immediately go back to the gear up position, and you do not have to wait for the gear to complete their cycle before you change direction. Likewise, we'll let them come back down, and we'll envision the opposite scenario. Let's say you've got gear down, and you take off and you start the gear up. The gear start coming up, and then something happens, and uh-oh, I need to land. Bring the gear right back down quickly so you don't have to let them go through the entire process. So, all right, I'm going to post this video to YouTube and send you the link, Wayne. And as long as everything looks good to you, I'll get her packed up and on the way to you. Thank you, my friend.